Students, welcome to Global Future School. I am Dr. Jad Bano, your chemistry tutor. It's chemistry first year, chapter number 2, atomic structure, and the topic for today's discussion is discovery of neutron. Students, before this we have learned about discovery of electron and proton, and this one is more fundamental particle that is called neutron. I already told you in previous lecture that neutron exists in the center of the atom, that is called the nucleus. And after completing this topic you will be able to understand the phenomena of discovery of neutron, how neutron was discovered, and you will learn about the nuclear reactions. Students, before discovery of neutron up till 1932 there was no significant work done after discovery of electron and proton till 1932. But in 1920, Rutherford just predicted that there are some type of particles that are neutral, that are present in atom, because atom couldn't be explained with the help of these particles, and they must be neutral because electrons are negative charge particles, proton are positive charge particles, and atom is overall neutral. If negative positive is cancelling each other, then the other particles must be neutral. And atomic mass could not be explained only with the electron proton, so there must be some other particles and that should be neutral. This was predicted by Rutherford. And finally, in 1932, James Chadwick, that was the from physics department, and he discovered the nucleus. He discovered the neutron with the help of experiment. And after only discovery of the neutron, after 3 years, the discovery of neutron, he got the Nobel Prize in physics. James Chadwick, who discovered the nucleus, who discovered the neutron. And his experiment consists of very simple apparatus, he used a polonium as a alpha source. Students, alpha particles are basically helium nuclei, double positive charge, 2 atomic number and 4 is its atomic mass. Polonium can also be used radium, but Chadwick used the polonium. Polonium is a radioactive element and it emits the radiations, alpha, beta, gamma radiations, and he attached this polonium to a spore, and this was emitting the alpha particles. These are alpha particles. These are called alpha particles. And he struck the alpha particle to a beryllium plate. This is beryllium. This plate is made of beryllium. And alpha particles that were obtained from the polonium. Polonium is a radioactive element. And then some particles were emitted that were neutral. They were not deflected by electric or magnetic field, and he gave this the name neutron. And its reaction will be like this. This Be, this is the beryllium, this beryllium plate. This was bombarded by alpha particles. Alpha particles, again I told you, this is basically helium nuclei, double positive charge, 2 protons. With 2 protons means 2 positive charge, and overall helium is neutral, and this was obtained from polonium. It can also be obtained from radium, but James Chadwick used the polonium radioactive element as a source of alpha particle, and just he used the alpha particle to strike the beryllium. What happened? This beryllium nucleus converted into the carbon nucleus. Before it has the atomic number 4, and when helium was adjusted in the beryllium particles, it converted into carbon atom, and then some particles were emitted that were neutral, and these were given the name as neutron because they were neutral. When they were put under the influence of electric and magnetic field, they showed no deflection. On the basis of this, they were given the name neutron and neutral particles. And this was his experiment, and further we will look up to this discovery. And further, when neutrons were bombarded on the paraffin, It also emits the protons. I will tell you this in the later part of the this lecture. Students, now we will come to the properties of the neutrons. What are its properties? Is it has some charged particle, or it has some other applications? First of all, um, as I already told you, neutrons, they were not affected by electric and magnetic field. Of course, they will be neutral in nature. That's why we say there is no charge on the neutron. And the free neutrons decay into proton with emission of electron and neutrino. Decay means breakdown. When a neutron is decayed, it forms a proton, an electron and neutrino. This is the equation. Decay of neutron produces a proton having one positive charge, electron having negative charge, and neutrino. These are also subatomic particles. They are emitted during decay of the neutron. It means a neutron split into proton, electron and neutrino. And these neutrons, they cannot ionize the gases like electrons or protons, but they are highly penetrating particles. They have the ability to penetrate. And these neutrons also categorized on the base of their energy. Neutrons that travel with energy of 1.2 mega electron volt or above, or more than this 1.2 mega electron volt, then they are called fast neutron. But the neutrons that have energy less than 1 electron volt, below 1 electron volt, it's electron volt, and above category is the mega electron volt, then they are called the slow neutron. And the other neutron that are between 1.2 mega electron volt and 1 electron volt, they are called intermediate neutrons. The other its property is that these neutrons, they can knock out high speed protons from paraffin, water, paper and cellulose. These paraffin, water, paper and cellulose, they are rich in protons, rich in hydrogen atoms. So when neutrons strike on them, they can knock out the protons, like this part. These are the paraffin. This can be paraffin. It can, if you place the water, if you place the cellulose or some paper, then when these neutrons strike on this paraffin or paper or cellulose, they knock out from this some protons. The neutrons, they have the ability to knock out the protons from proton rich source. So this is their ability to knock out the protons. And slow neutrons are very important, and they are very effective in fission process. What is the fission process? Fission process is the breakdown of higher nuclei into some smaller weight nuclei, and during which high energy is released. When heavy nucleus, they break into some other light weighted nuclei, during which the energy is released. That process is called fission process. And the slow neutrons are more effective in fission process as compared to fast neutron, because controlling fast neutron is very difficult as compared to controlling slow neutrons. When neutrons are used as projectile, just like a parabolic movement, they can carry out nuclear reactions. Students, we have learned about reactions like reactants are converted into the product with the adjustment of the electrons, positive charge, negative charge, they form in bond between electrons. But this is here nuclear reaction. It means the reactions that involve the nucleus, during which change of nucleus takes place. Those reactions are called nuclear reactions. For example, nitrogen, its atomic number is 7 and its atomic mass is 14. It means its nucleus contains 7 protons and 7 neutrons. When a neutron is bombarded on it, its nucleus change, and now it has 2 particles, boron and helium. In boron there are 5 neutrons and 6 neutrons and 5 protons, while in helium there are 2 protons and 2 neutrons. So one nucleus is splitting into more than one nuclei. These are called nuclear reactions, and these helium nuclei are also called alpha particles. Overall number of electrons, protons and neutrons are equal on reactant side and product side. Similarly, in another example, when slow neutrons hit the copper metal, beta radiations are emitted. So beta radiation basically are electron in nature. Copper, its atomic number is 29, its atomic mass is 65, and one neutron hit a copper. This atom, this nuclei that containing 29 total proton and neutron convert into zinc. That zinc contain total 30 including proton and neutron, and as well as beta radiations are emitted. What happens in this nuclear reaction? You can say there are 29 and now 30. Where it comes? Basically, I told you when a neutron is decay, it gives a proton with mass and one positive charge, an electron with this one is the zero mass and negative one, and plus neutrino are chargeless, massless. And you can say this one is this one beta rays, and this proton when one comes out of this when a neutron split, it gives proton, then this proton calculated in the atomic number, now it's come 29 to 30 because atomic number is the number of proton, and this proton mass is also calculated in its atomic mass because atomic mass is number of proton and number of neutron. So previously this was 65, by adding of one proton now it will become 66, and previously its atomic number was 29, and by adding of one proton its atomic number will be from 29 to 30. So there is a change in the nucleus of the atom. So these are the nuclear reactions, during which beta radiations are emitted, and due to their intensive biological effects, they can also be used in the treatment of the cancer. This is its very important application for the treatment of the cancer. Students, here are some short response questions of 3 marks, and usually these are asked from its properties. If you understand the properties very well, then you can answer these questions very easily. Which species are formed by the decay of neutron? I have told you in this lecture, also repeated, that when a neutron is decayed or split, it produces proton, electron and neutrino. So decay of neutron produces proton, electron and neutron, and you have to write this equation too while answering the question. Similarly, question can be asked, how you prove charge on neutron is zero? Of course, we just predicted the charge on electron is negative because it was deflecting towards the positive pole. Proton is positive because it was deflecting towards the negative. But in case of neutron, they do not deflect to either positive or negative pole, so they are neutral in nature. So this proves that neutrons are neutral particles. They have no charge, they have zero charge. What type of neutrons are more effective? I already told you slow neutrons are more effective. Why? Because they are used for fission purpose. What are nuclear reactions? Just I told you, we discussed in this lecture nuclear reactions that involve the change in the nucleus of the atom, and also give the examples that I already quoted the example in this lecture. Question can also be asked about differentiate between slow and fast neutron. Then tell them about their reference to the energy. Slow neutrons have energy less than 1 electron volt, and fast neutrons are the neutrons that have 1.2 mega electron volt or more than this. They are called fast neutron. So students, today in this topic we have discussed discovery of neutron, its experiment, its properties, and particularly the nuclear reactions. And our next topic will be the discovery of the nucleus. Up till electron discovered, proton has been discovered, neutron has been discovered. Then we come to know in this topic where this neutron, proton, electron exist in an atom.